just stay on that middle board up here. All right, here we go. There's not much here yet, but what you can do is every time we have another test, you just bring the new formula sheet with the others. You can just keep bringing all the formula sheets with you. Right, as long as it's not one that you lost points on, you probably want to write that over again. So the very first formula we learn, like chapter 1 is all definitions. Chapter 2 is histogram stuff. You have to know the class width formula. You have to know that on the quiz. So the real first formula that we hit were these formulas here. Right? And if you didn't want to write these down, I wouldn't blame you, because you know how to do those. If you want to, go ahead. Oh, plus, we all know how poorly I write. So if I'm you, I'm going to double check any formula that you wrote down from here against what's in the book, just to make sure you didn't write it down, see it wrong. You with me? Then, of course, we get, there's no real formula for the median, truly. There's sort of a rule of thumb to get it, but you can't write that down. Mode is an idea. Mid-range, I can let you do that. This is one of the few words you're allowed to use, because there's no mid-range symbol. And what's the formula for the mid-range? Who knows? Yeah, the average of the high and the low, right? So you do not have to spell correctly on your formula sheet. That's all right. Yeah?
We put a big plus, like P-O-U-S, instead of low plus sign. Are we cool with that?
No, you better just put the formula. Be careful. The only word you're allowed to have on here so far is a title and the word mid-range. Yes, sir. Ma'am.
So the mid-range, like, technically can be bigger than the highest plot or the highest number. So, but then, like, on the practice test, it was like 60 plus 29 divided by 2, and my calculator told me it was bigger than calculator.
All right. Well, see, this is why I said that's the formula sheet. Now here, if you do 60 plus 29 divided by 2, the calculator knows order operations. It's going to divide first and then add 60. When what you meant to ask it was this.
Yeah. Okay. That makes sense.
This happens a lot, especially when we get to the larger formulas, and we really want to do it all at once, so we're not trying to write millions of decimal places out. If you don't put it in the calculator correctly, it's going to spit trash back out at you. Right? So I'll try to make a point of showing you exactly where to put the parentheses in these formulas. All right, so back to the formulas. Let's see. I don't think we hit anything else up until standard deviation after this. And if you have anything else you want to suggest up here, just let me know. So we have the variance. The book tells you, I used to teach this alternate version of this, and the book has an even worse alternate version of that. But I'm just going to stick with that. So if you want to, you can write down here also, square root version of this, but they're both really the same thing, right? Now you definitely, what's that for specifically? That is a standard deviation for a population. Cool. So you definitely want the other formula down, because what happens in the formula for a sample? N minus 1 on the bottom. I like it. So you're right next to it. Squared. All right, they're really the same formula. It's the symbols that represent those various ideas between population and sample. Okay, cool. And then I think the next real formula we had after that was z-score formula. All right, if I'm not mistaken. I think this pretty much covers it. You can have that one and that one. But again, these are the same damn formula, right? Just my score minus the mean divided by the standard deviation, they both say that. It's just that one's for a sample, one's for a population. You can't put next to here population. The only words you're allowed to have on your formula sheet are the words formula sheet, if you want, and the word mid-range, and high and low are almost words, so we'll say those. just be very careful. Don't make any assumptions about what else you could put on there. If you want to put something else on there, check it right now. Or make sure with me before the test. Don't turn in a formula sheet that's been torn or something, because then exactly when did that tear occur? Don't turn in a formula sheet that has something marked out, because again, exactly when did that marking out occur? You kind of with me? Be very careful. If that happens, I got to assume the worst. Don't make me do that. All right. Does everybody understand what's happening here right now? So I don't make you memorize most formulas, but I do make you recognize the formulas. So you have to know when to use which. Yeah?
Would we be able to put on there the rules you did for standard deviation? Put in one standard?
You got to know those. So remember I said you have to realize chubby dude exists, chubby chef. And empirical is the one you got to know. You got to know empirical rules. So we can do some examples of that today, but you have to know those three numbers. So within 1 is how much? 68%. If it's a normal curve, right? Within 2? 95. Within 3? 99.7. So if you have a normal curve and you go out 3 standard deviations, you basically caught everybody. There's 0.3% you didn't catch, and those are definitely weirdos. Or maybe not that extreme of a word, but they're out there. They're unusual for sure. And right now, what does unusual mean? It means it's outside of how much? 2. So it's either more than 2 or less than -2. Right? Because then that's pretty far away from what you expect. And what do you normally expect? You expect the mean to happen, somewhere close to the mean. Yes, ma'am?
The standard deviation formulas, can we write it so that this, what it equals is just the variance on the formula sheet?
Oh, you mean like this?
Yes.
Sure. Okay. Sure. Like that?
Yeah.
Yeah, okay. All right, so any other suggestions of something that should go on the formula sheet? So if you're wondering, if you're curious, if you have a new book, it comes. This is why I don't teach English. It would be so bad for our future. It comes with this thing, like a map, and it's got a formula piece to it, formula sheet piece. But you'll see how many freaking words is on that thing. No. Don't try it. Don't use it. Don't. You can't. Too bad for you. You can use it when you're doing homework, but it's got way too much explanation on it, which is good for homework, but it ain't good when I want to test you. You guys, so don't even use that insert for the test. Don't try it. It's bad. All right. Cool. Okay. So no more suggestions? That's it then. That's it. Okay. So everybody got that? It's been recorded. All right. Everybody has this? All right. So now it's wide open to whatever you want to talk about. So sometimes I try to work backwards a bit for review, do the most recent stuff, and then work our way back. Unless there's any specific questions from the... I've got the answer key for the practice test that I will give you a little bit later. All right, so if you don't have much to do and we're talking about something you understand, you could do the practice test. You could do quiz corrections. If nobody's asking any questions, the floor is yours. Ask away. Keep on asking if nobody else is asking a damn thing. If nobody asks anything, we're just going to stand here and look at each other. Yeah.
For number 1, F, it says what percentage of data is within the standard deviation. Is that just the empirical rule and it follows it, or is it
So this is a really good, so now, it's not the formula sheet anymore, right? Now we know this empirical rule, and Chebyshev's theorem, right? This is what I was saying when we first got into standard deviation. We did that problem on the handout that said put the mean in the middle. Go up 1 standard deviation, go down 1 standard deviation. You guys remember that? Okay, 2 people said yes, so I'm going forward. And then we just looked to see at the list, and we said how much data actually fell in there. I really want you with me here, because that's a very concrete example of these freaky theoretical things. Empirical rule, Chebyshev's theorem. Now this is not really theoretical, it's what's been observed with truly normal data, but how much in life is actually exactly normally distributed? Basically nothing. So it's still sort of, to me, it's still not concrete. It's sort of an ideal. So I love that kind of problem where you have to calculate a mean, and you calculate a standard deviation, and then you actually go up and down one standard deviation, minus a standard deviation, plus a standard deviation, and you see how much data did you catch. And if you caught like 68%, maybe it's normal, because within one step of the mean and for a normal is 68% of the data. You guys semi with me? Just a little bit. But Chubby Dude says it could be almost anything. Because Chebyshev says it's at least 0%, which is saying it could be anything. Right? We had that one example with the ages in Florida. You could have nobody in the middle, or you could actually have everybody in the middle. Those are the two extremes. All right, so I love that example. It's a concrete. You calculate these. You look at the data. You count what's in there. It's not a theorem. You can actually just count it. So whenever I ask you that question, 1F. Here. If I ask you 1F, what percentage of the data is within the one standard deviation of the mean? Don't reference one of these. Actually go count how much of your data is in there.
So, and then you also mean like negatively and positively, right?
Yeah, you go up. Yeah, within one step means up and down.
So like you would add that together, right?
Yeah, so if this was 4 and this was 10, then if there's 5, 6, 8, and 9, those 4 data points are in there, right? So I would say 4 out of however many data points.
Oh.
Cool. Just like we did on the handout, right? Yeah.
The 4 and 10 would be dependent on the standard deviation.
Yeah, if the mean was 7 and the standard deviation was 3, wouldn't this be 10 and 4? So if that was what you got, you get between 4 and 10. And then you just look at your data and say, what data points are from 4 to 10? So it's exactly like the handout I gave you. So those handouts are good because that's exactly the way I ask questions on tests, for example. Right? So those handouts are really good to review. Guys look so forlorn. I don't get to use that word much, but it's exactly what comes to mind when I look at some of you guys. What am I doing here? I'm sorry. I'm a math teacher. I'm used to it. Sorry. Okay. Yes?
How many questions will be on the test?
So when roughly in the 20s, so 24 roughly.
Is it going to look like this, like how we'll have like no
Yeah.
or will it be like one in between? Or?
No, it depends on how I feel. Yeah. If I give you it like this, and I just gave my pre-calc class a test just like this. So I had scrap paper if they didn't have paper, and just had to organize their work. So yeah, I don't know. It depends on how I'm feeling. Depends on if I have time to go to the print shop or not. If I don't, I squunch it all up. My poor little printer screws up every now and again. You know, it's an economics thing. All right, so let's do this. The last thing, so the only thing I need you to worry about from section 3.4 is the idea of z-score, right? Let's do some empirical rules, z-score kind of problems, and then just kind of work our way back. If you have questions, ask away. This is all about what you guys want to cover. I didn't really come prepared, but since nobody wants to ask me anything, we're going to do this. So a real quick, very straightforward problem. Let's say we have, the mean is 123.4, and the standard deviation is 11.29. And I want to find a z-score for do those two real quick for me. Say again, sorry?
Sorry.
Yeah, find the z-score. All right. So you guys can work together. You can call me over for help. You said you wanted to have live classes together. Remember the thing we do is we roll at 98. More tick marks, more scale. Because it will help you place the bars better. But really, the main thing is to draw. Don't say class. Just say which one you're using. So I was being regular Stanley picking, especially Stan's teacher is the it's this is yeah, there and yeah, so you can say grades on math 162. Yeah, be a little bit more specific. Yeah. So that's right. You do it on here. No, I make it for garage. Wait, so just redo the last class. So now that one of those is down. No, it's been 98. Just make it less than 8. Are we allowed? Yes, and that's what we talked about. That would be wrong for the form. We would add one. So you pick the one that's
Actually, Austin, sorry, I'm like really bad.
so that number 3 is completely separate problem from the first two. Right? Yeah, so if this is normal, if the mean and standard deviation came from a normal distribution, so 1 and 2 is just two separate little problems.
So I asked 11. Yeah, but one standard deviation.
So that would be one step. One step would have how much? 68. So to get 95, we've got to go out.
I'm sorry.
I love problem number 4. Not because you feel like you don't have enough information for it, but because we totally do. I just want to show you how it works. How do you do number 1? Yeah. So x minus the mean divided by standard deviation. And what do you guys get for that? 2.09. 2.09? So is that data point officially unusual? Yes, good, because it's more than 2 steps away, more than 2 standard deviations away. That's kind of unusual. Why is it unusual? Because it's outside of where 95% of our data would be expected to be, right? So the idea of unusual actually jives with what we think of as unusual in real life. If somebody had a height of 2.09 standard deviations, they would be unusually tall. They would be somebody that we kind of go, I don't see that tall of a person very often, all right? And this guy, same setup, but what's going to be true about his z-score? It's got to be negative. You know going in, it's got to be negative. But people often just subconsciously or something change these because you're trying to save it from being negative or something. But It's below the mean, so it's going to be negative. So what do you get there?
Negative 2.87.
Negative 2.87.
2.87? Yeah. Somewhere there? Okay. And again, that's also unusual, right? Unusually low in this case. So if this is your golf game, you're doing really, really well. Right? Where Tiger wishes he was again. Sorry if it's his Tiger. Yeah, I feel bad for him. He's got something going on, but he deserves some of it. I don't know where you guys stand on that. If this is normal, if this distribution was normal where these came from, what am I using to answer these two questions? Empirical rule, right? And it's the three numbers you have to know. So 95% would be between how many? 2 standard deviations. So all you got to do on this kind of question when it's an empirical or Chebyshev rule, you pretty much always set it up. You put the mean in the middle. And in this case, I got to go up and down 2 steps. So if I add 22.58, right, add 2 of these. Is everybody with me here? Everybody that was just telling me what to do is just suddenly become quiet. So add 2 of those. Where do you end up? 1. And if you take 2 away, subtract 2 of these from it.
100.82.
Okay, 100.82? Yes, ma'am. Which one? Okay, so all I'm doing, 95% is within 2 standard deviations, right? That's what the empirical rule says. Is that by itself cool? Okay, good, right? I don't like the way you said yeah, but you're with me, right? So it's normal. I use the empirical rule. The empirical rule says 68's within 1 step, 95's within 2 steps. And the word within, people freak out about the word within. But if I said, guess my weight, and I'll let you be within 10 pounds, then that means I'm going to allow you to be 10 pounds over or 10 pounds under, right? We kind of know that inherently. And that within is like the standard deviation. It's sort of like the error. It's related to that standard deviation in a way. You guys kind of with me? Have you ever gone to a state fair or something? They sometimes have the people that guess your weight or guess your age within a certain number of years or a certain number of pounds. All right. If you've never been, I'm sorry. You've just barely lived. And then so I get this number by adding, if I want to be within 2, I want to go up 2 of these. So I add 11.29. Is that what it was? Yeah. And I add another 11.29 to take 2 steps up. So that's why I like to call them steps, because the way these rules and theorems are built, I am stepping up and around the mean with standard deviations. So if I subtract 11.29 and subtract 11.29 again, I end up down there. So between what 2 data points will we find 95% of the data if it's normal? Between 100.82 and 145.98.
I thought it was 2 steps was 89%, 3 steps was 95%.
That's if I don't know what kind of distribution it is. That's Chubby Dude. That's Chebyshev.
Yeah.
So guys, what kind, guys, and girls, and whatever other designation. I want to be inclusive. When can I use Chebyshev's rule? All the damn time. It works for anything. When can I do the more specific empirical rule? If it's normal. It only works for normal. Chebyshev is still true for normal distributions. It's just I could be a lot more specific because now I know what the hell the thing is shaped like. Right? So that's why empirical rule is so much more specific. So here I said it was normal. So empirical rule says 2 steps is 95%. It's 68, 95, 99.7. Yeah, those are the 3 you got to know. Chebyshev, I just said I had to know it exists. Yeah.
See, normal is empirical every time, pretty much.
Yeah, empirical was built for normal distributions. I like it. Chebyshev is just like whoever the hell, and that's why the first thing in Chebyshev is so lame. At least 0%. Well, you got to give it. You got to be okay with that because he's doing it for any freaking distribution ever. So I'm okay with that. All right. So you would say between 108.82 and 145.98. That would capture 95% of the data. How we doing? All right. And then what percent of this one I really like? 134.69, wouldn't that be one step up? So let me draw this out. We know it's normal, so let me do a little normal curve here. Here's my 123.4. Here's my 134.69. So if you shaded in the area I'm talking about, where would it be? I like it. Up there. Is that cool? Do you guys see that? Because I always get people that see this, they see that it's one step up and they just say 68%. But where would 68% be? It would be here. Is that my question? All right, and then the next thing is once you realize that 68% is not the answer, you go, well, how the hell do I get that? Right? Yeah, so if this is 68% here, how much is outside? And how much is on that side? All right, we're done. 16%. Done. So you see, so you have to not only do you have to memorize 68, 95, 99.7, you should also be able to just manipulate them a little bit. If there's 68% inside, how much is outside? 32%. Let me stop right there. Does everybody see where that 16% came from? If you don't, trust me, at least 10 other people also don't. They just don't want to say anything. Yes, ma'am. Okay. Well, the 68, I hope you know where it came from. Because that's empirical rule, right? The empirical rule says within 1 is 68%. Now, a good question would be, I know that, Jeff, but why has that got to do anything with this problem? Because that is one step up, right? That is one step up. So to figure out what's out here, I could actually figure out what's out there by figuring out what's in here. Yeah, okay. Oh, all right. That was a good sound. All right. That was a click. Let's do another one of those, because I'm going to put it probably down on the test. So for the same set of data, what percent is below, 100.82? I'll use something that we know already. So what's 100.82? What's special about that? Yeah, it's 2 steps down, right? Yeah, it's 2 steps down. So I'm asking you, where's the area that I'm asking for then? Down here, right? I'm asking you what percentage of the people would be down here or something. Okay, good. And this is related to what number from empirical? 95%. So that would be in here, right? Within 2 steps is 95%. So that's not my answer, but it's related to that. So they do it the same way. If there's 95% in there, how much is outside? And how much is on that side? 2.5. So there's 2.5% below that. Do you guys see how to manipulate that? Do you see that? Yes, ma'am. It's an excellent idea. If you, it's not that you have to; it's that you really should. It helps you do the problem. If you label what's going on.
What is percent below 100, right?
Say again?
That's all that's going to be on the test. Is that question that we can draw to help us, right?
Yeah. If on that problem it just says this, it says it's normal, and then I ask you this, I would definitely draw the picture out to help me figure it out. Right? All right. Cool. Yes, sir.
If we draw that, it's okay. Like,
If you do exactly this.
yeah, exactly.
I only circle that because somebody asked me a question. Circle the answer, make sure that I know what your answer is.
Okay.
That's beautiful, right? Yeah.
That number 100.82 is like perfectly 2 steps, like just outside the range of 2 steps down. If you had one that was like 100 straight up.
I love it. That's chapter 6. Right now, we only know empirical rules, so we really can only manipulate it so much. For the minute, I'm like 1.13 steps away. We ain't got shit for that, right? So then we're going to use this giant chart that's actually in your insert in the back of your book to help us fill in. I call it empirical rule on steroids because it just fills everything in. That's in our future. So right now, I've got to give you a number that's perfect because we ain't got no other way to do it otherwise. Showing off my grammar. We ain't got no other way. All right, cool. Let me stop here for any specific questions about anything before I make something else up. Yes, ma'am.
I'm more confused on how you get the 2.5% and the other, the 16%.
All right, let's do this.
You're supposed to add them to specific numbers.
So let's do this real quick. So if I have a normal distribution, I'm going to represent the mean with 0. So what am I really putting down here? What are these? Z-scores. I love it. So 0, of course, because the mean is 0 away from itself. And then 1 step up and down. Cool. Scale sucks, but we'll be okay. So within 1 step, there's how much? 68. So how much is from 0 to 1? For example. 34. See, so if you memorize 68, 95, 99.7, you can start playing with it just like this. And it's not that it's difficult. It's just that you got to get used to how to do it. And then in here, there's 95%. So let me ask you this. Can somebody figure out how much there is in there?
Minus 68%.
Say again?
95 minus 68%.
It's 47 minus 35%.
Yeah, so there's a few different ways to do it. If you do 95 minus 68, where is that? Be careful. That's both of them, so then you just have to do what with that number? I love it. There's another way to do it. So one way to do it is 95 minus 68. That would be what's in here but not in there. Do you guys see that? 95 minus 68 must be in here but not in there, so it must be out here. But what's my question? Just there. So then you cut it in half. So that would be 13. Is that what you're saying?
13.5.
Okay, thank you. I thought you were saying 30. I'm like, wait a minute. You got a problem. So 13.5%. Real quick, another way, that's not even the way I was thinking about doing it, which I love, because there's so many ways to do it. This was 34% again, right?
That's 34%.
You with me?
Take that.
Right? I don't even know if I like this one now. I think this is 2.5%. We figured that out earlier. And this whole piece of it, how much is above here? How much is totally over here? The mean cuts it in. There you go. So this is 50%. So if you do 50% minus these two, you end up there. And there's even other ways besides that. I mean, there's other ways to do it. It's just playing around. Now, if you couldn't do any of this if you didn't memorize those numbers, so that's the most important thing to do. But then this is not that big of a step from that. And I'm not going to give you anything too freaky, because you can imagine I can give you some freaky stuff. I'm not going to try to make it too freaky. Trust me. Okay. What? You're like, trust a math teacher? Never. All right, so anything else before we go back another step? Yes?
I have a question number 9 on the packet.
Yes, cool. Okay.
Maybe I missed that listed.
All right, so I do this on purpose sometimes, and sometimes I do it, to be honest, I'm a human, I just forget to talk about something. But this is why I ask if there are questions. So sometimes I get worried if nobody asks me certain questions, because I didn't talk about it, and I know it's a little bit weird, and nobody asked me, I'm like, shit, nobody's doing the homework. So the discrete and continuous thing, we did talk about it relatively quickly, and it's in the homework. But here's the idea. If it makes no sense, let me see how to come at this. The reason that word continuous makes total sense is because if a variable is continuous, that means its value could be anything in a continuum. So and that sound is like, thanks for that, Jeff. But if I said, how heavy is your backpack? Well, what kind of variable would that be? It won't be discrete, because how heavy could it be? Anywhere from 0 pounds, right? It really can't be 0 pounds, but it could be almost 0 pounds, up to whatever it could actually hold before it breaks or whatever, right? It could be any value in the middle. And if you're looking at me like I'm crazy, don't think about what you would tell me. You wouldn't tell me that your backpack weighs 5.934 pounds. But could you tell me that if you knew it? Could you get even more precise? If you got a very precise scale, could you get crazy precise? Yes, you could, and it makes sense. So what value could the variable take on? Not what variable does it. So if I said my backpack weighs 8 pounds, what kind of variable is that? You don't say discrete because you see the number 8. You say, what could it be? That's what tells me what kind of variable it is. If I ask you, what about the number of doors on your car? Could that be anything in a continuum from 0 to something? I have 2.943 doors on my car. Am I, what? Yes, sir?
What if I already knew how much my backpack weighed?
No, you don't. You think you do?
Alright.
I'm not trying to be evil. But like if I said, how far away do you live? You're not going to say the right answer. You're going to say about 15 miles or whatever. What's the right answer? It could be 14.7249963 miles. And that's not even,
But I thought it can be measured though. And I thought discrete was things that can actually be measured, unlike
Discrete is things that can be counted.
Right.
And you can't count all the values of weight that your backpack could be, because your backpack could weigh 0.01, 0.001, 0.0111143. It could weigh anything in the middle. You can't count that. It's uncountable. It's not even countably infinite. Yeah.
Basically, continuous something that is open to change. So it can change the weight of something can be changing.
Sure, but I can also change the number of books on the table. Right? But the number of books on the table, would that be continuous or discrete? So really, here's a rough thing you could do for yourself. You could say, but if the problem is number of books on the table, you say to yourself, would 7.3948 books make sense? Would it? Hell no. Right? What the hell is a 0.48 of a book? What is that? I don't care if you cut it in half, it's still like part of a book. Or people's better, of course. Even if you lost a limb, you're still a person. Right? Your door's a door or not. If it's not working, you still don't count it. You don't just count it half. Right? You with me? So that's kind of a test you could do for yourself. Would it make sense? So if I say the liters, we're in America, the gallons of gas that we put in the tank, we would never say what it really is. We would say I put about 11 gallons in there or something. But would it make sense? Could it be 10.543963 gallons? Is that possible? Of course. If you had a way to measure it that precisely, right?
So mostly makes sense.
So measurements are definitely, I gotta be careful. Almost definitely going to be continuous. Yeah. If you can measure the number of people in the room though in a way if you want to really stretch the definition, but true measurements, scale measurements, measuring the temperature, right? So it's not what you normally would say; it's what you could say. Could you be Spock for a second? Is that reference all right? Spock would say 2.479 years. It's like freaking 2.5 spot show. Could you do that and would it make sense? You can't say I got 2.539 kids. Again, that's scary. I'm not coming to your house. 0.539 kids. Look at it. What is that? Sorry. Nobody has 0.539 kids. There should be a campaign. Nobody has 0.539 kids. Everybody's like, what the hell is that?
Gas, though, it's like weird.
Okay. So here's the next thing. The price of gas. Could the price of gas at the pump, what they have listed, could it be 2.486934429634 dollars per gallon? Will they have that listed at the pump?
No.
I like you shaking your head. No, right? No. So just because there's a decimal in it doesn't mean it's continuous, right? Kind of with me? All right, good. There you go. So a continuous variable means it can take on any value. It doesn't jump over values. What does price do? It jumps over values. And I know there's a third decimal that's normally a 9, right? You ever notice that? It's like 249 and 9/10 of a cent, right? That little 9 at the end. But they don't go any further than that. Because, so that's discrete. Discrete means it jumps over possible values.
There's a finite number, yes.
Good. You can count the number of possible values you could have. Right? But I like to think of discrete as being, it's just this or this or this. It jumps over. So the number of doors in a car could be 1, or it could even be 1.5. Don't they have half on trucks? Don't they have half doors? We'll be cool with that. So you can have, now 1 door is kind of weird. Just a porthole in the top. Right, we don't drive a tank normally. So we'll say like 2 doors, 3 doors, 3.5 doors, right? So what are you skipping? You're skipping 2.18, you're skipping 2.97, you're skipping square root of 7. You're skipping a whole bunch. But of course we are. They don't make physical sense. But weight could be anything between maybe 0 almost and something up here. It could be anything in there, right? You just put some grains of sand in there and suddenly the weight's changed a little tiny bit. Because you can measure that precisely. But you can't measure the number of doors in your car more and more precisely. Right? I've got 3.00000 doors. I'm like, who are you? What's happening? All right, maybe. Some of you guys still look really, really either angry with me or really sad. Very hopeful. All right, anything else? Yes?
How about that? Yeah.
Are we cool? Are we decent with the discrete continuous debate? Yes?
Yeah, I have another
Wait, say a second.
I just wanted to know 8B, if 183 students were population, or...
All right, I love this question. 8B.
Yeah.
The biggest, really? There you go. Sweet. 2 birds, 1 stone. The biggest mistake I get with 8B is people tell me that the sample is 14% of 183. And if you say that, you're telling me that I happen to randomly pick the 14% of people who enjoy parking at Grossmont. What's the probability that that's who I pick? That's who I pick. That's it. Just those 14%. Very small. It's not going to happen. So what is the 14%? What's my actual sample? I pretty much tell you directly. Yeah. What's the 14% then? It doesn't have anything to do with this question. I hope you realize that. But what is the 14%? It is a statistic, right? Because it's something I did with my sample. It's a measurement from my sample. That would be a statistic. It's very similar to 4A. So somebody was asking me about number 4 earlier, and the way to look at that kind of problem, if I ask you what level of data is this nominal ordinal interval ratio, you say, what would I actually be writing on a clipboard when I'm talking to people to gather the data? So if I'm walking around for 4A, what am I actually looking at or asking people for 4A? So what am I listed on my clipboard? Hair colors, right? Where did the 30% come from? Again, what would 30% be? A statistic. It was 30%, right? You aren't looking at me like I'm crazy. Okay. 30% would be a statistic. It's what I did with my data. What's my data? Hair colors. What kind of data is that? What kind of variable is that? Beautiful. No. So don't look at 30% and say I can divide ratios. No, that's not the data, right? And that's why on the quiz, if you guys said that for those kind of problems, I circled the word data, and it's the data. It's the blonde hair. It's the strongly agreed. Some of you guys had that on the quiz, right? That would be ordinal data. There's a gimme, right? Average temperature. We always assume that I'm not going to use Kelvin because we all don't know Kelvin. Not all of us know Kelvin. That's grammatically correct. So I'm talking about Fahrenheit or Celsius. What would that be? Why is it not ratio? 0 is not in the right place. I love it. Or 0 does not mean the absence of heat. Thankfully. Or else people will be dead in several parts of the country. But what about the average number of TVs? Yeah, because again, and when you answer that question, be specific. Don't just say, I could divide it. Show me. If he had 4 and you had 2, 4 divided by 2 is 2, it's twice as many. Next question, right? You gotta, don't just say what has to happen. Show me that it happens, right? Okay, cool. Would that be discrete or continuous? 4C. And be careful. It's not continuous because there's a 3.7 there. And there's a question in the homework about can the average number of girls be 2.5? Is that okay? Out of 5 kids, the average number of girls is 2.5. Of course it can be, it's fine. I'm averaging, I'm dividing, I can come out to 2.5. It doesn't mean that somewhere there's 2.5 kids. It just means the average is 2.5. If I thought the average was 3, now I've suddenly increased the number of girls in the world, right? It should be 2.5, so it's 50-50. It's got to be 2.5. It's just too bad for us. So don't say you can't have a kid. That's not at all what the question is. So part C, 4C, if I asked this question, if I said is it discrete or continuous, it would be discrete. No TVs, 1 TV, 2 TVs. You can't have 4.7 TVs. I don't care if it works some days and not others. And what about part B? 4B, is that discrete or continuous? The temperature, is that discrete or continuous? Continuous, because I can get a very, very, very precise thermostat and just get it down. So saying it's 80.39467 degrees Fahrenheit makes sense. It could actually happen if I had that perfect of a measurement device. All right. If I knew the English language, I'd have an easier time. Yes?
For 4C, if you wanted us to explain why we know that, would we just make up like numbers and show you how we divide it? Because it doesn't really actually give you like the numbers.
Oh yeah. You
So
totally can.
Make up an example.
Because I really want you to understand just like discrete and continuous is what could the variable be? What value could it have? Nominal, interval, all that stuff is the same idea. What could it do with each other? So you have to give yourself 2 values to work with. Like the cop stopping the cars. If on one day he stops 8 and on the next day he stops 16. 16 divided by 8 is 2. It makes sense. Not just can you divide them, but does the answer make sense? Twice as many cars stopped the next day, right? Okay. Ooh, I'm sorry, I just skipped somebody over. Yes?
So for number 5, would we just say it's like usual or normal?
Oh, okay. All right. So what did I tell you guys? And actually I put it on practice test too. I'm pretty sure I said this. Every single test in this class, yes, I did say this. There will be, a question that will be on every single test already. What question is that? Yes, that's the answer. But the question, that's sort of the answer, I think. What does the z-score tell you? And this is a variation of that. What would a z-score of 1.52 tell you? A z-score can only tell you one thing. The unusual thing is a way that we use z-scores. So if you tell me, it would tell you that it's not unusual, that's not quite good enough. It doesn't tell me what the z-score itself tells me. I don't know if that makes sense or not, but the z-score only tells me one thing, and you can see it from its formula. What's the formula for z-score? Oh, crap and a half. Z-score tells how far a data point is from the mean in standard deviations, right? And actually, we'll develop an even better formula that's the exact definition later. Too bad for you. But a z-score is always telling me how many standard deviations from the mean to the data point. So if I had a z-score of 1.52, what does that mean? That data point is?
1.52 standard deviations away from your...
I love it. And even better would be if you said above the mean, because it's positive, but I'm not going to get that picture. As long as you stay away from the mean, you can ask. Yes?
So for my answer for number 5, I said it would tell me that the data point is part of the average normal, also known as less than 2 standard deviations from it. Would that be like an okay answer?
No.
No.
You're almost there, because you said that less than 2 standard deviations from the mean. But I needed to be precise. The unusual thing is not what the z-score itself tells me. It's something we put on top of it. We say, what's a z-score? Oh, okay, let's use this definition of unusual over here to figure something out. Z-scores just tell me how many standard deviations from the mean to the data point. That's the only thing a z-score can ever tell me. What will we use that information for when we get to chapter 6, 7, 8? we'll be using z-scores to do a lot of shit. But they always just tell me one thing. That's all they ever tell me, one thing. How far from the mean to the data point in standard deviations. Don't just say the distance to the data point from the mean. What am I going to do? I'm going to be the true dork that you know I am. I'm going to say, in miles, in light years. It's not even funny. But it's too damn bad because I'm going to do that in standard deviations, right? The number of standard deviations. That's the unit of measurements in statistics is the standard deviations. It's how I measure things. I'd love to look at some of your face. Alright, maybe. Yes?
What are the odds I win the Powerball?
Tells you on the thing.
No, it does say?
I don't even know. I'm kind of happy that I don't know.
Really? Do they use statistics to find that out?
Oh, hell yeah. I mean, they use basic probability.
Just how many people?
How many combinations are possible. They base it off of how many combinations are possible. So the computer's going to randomly pick a combination. So the probability that you win is dependent on the probability that the one combination you pick out of all the possible combinations.
So it doesn't even matter how many people play.
Well, the number of people that play have to do with how much money you can get.
Right.
Right?
But it doesn't change the probability that you're not.
It doesn't change the probability that your pick is going to win.
Actually, isn't that very simple? How many numbers do you choose from?
It's just 6. There's 5 and then a Powerball.
But how many is like a total of 70? I think it's just there's 70 choices for your first, 69 choices for your second, 68 for your second.
There you go. Good.
You just multiply it all the way out.
Permutation. Look at you. So chapter 4, we'll talk more about that. Yes. Yeah, so that last question, number 10. I like that question, that kind of question. I'm not going to ask exactly that question, but I never like to ask you a direct definition question, but I like the idea of create an observational study. So you really have to be careful about how you set it up. So who wants to give me an example of something they came up with?
I'm observing, like for the observation, I'm observing grass grow over a year span, and then for the experiment, I'll add chemicals to the grass and observe it.
Okay, cool. So you observe grass growing, which some people would say, I'd rather do that than statistics, but that's okay. Or paint, watch paint dry. Watch grass grow and see how it grows. And this is exactly what is done, to be honest. And then you see different chemicals applied to it and see if it changes the rate of growth. I love it. Yes. So that's observational study. It's not like you don't want the grass to know you're there. You're just not changing the environment. Right? You look at that place. And then you put on a load. Kick ass.
How many places do you run a z-score? 2.
Yeah, 2. Yeah. So on the test, I'm going to try to remember to put down what's around your number 2. But we already know a couple things. Z-score is normally 2 places. Standard deviation, you have to go out 3 places. I like it. Yeah.
For 5, it will be okay if I write that it tells you that your data point is 1.52, a standard deviation above the mean.
Kicks ass. Maddie.
Number 1, those are samples, right? In 15 days. So for like E, for the variance and standard deviation, you use.
Yes, you use the sample. And let me say this in general, just in case I'm not clear with the way I decide to word something. I have to be really, really in your face about it being a population if it is, because we normally have samples that we're working with in statistics. So if you can't really see anything, if I don't say it's a population, you have to assume it's a sample. So on that number, I don't say if it's a sample or not, but it is over the past 15 days. I don't say, though, but since I don't say, you have to assume it's looked at as a sample, because that's what we normally work with. We kind of like yell it from the rooftops if we have a population in statistics. You're like, we got a whole freaking population? Shit, we know more than we normally know. Shit. So we want everybody to know this is a population, this is a population. So we don't say, we're like, so good, just a sample. We don't really know. But let's figure some stuff out. Right? And it's not really an accurate representation. Yes?
6A will be false.
Yeah, it's false, because they can totally be the same. Yeah. And one way to explain it is just to give you an example. And the easiest example there is 1, 2, 3. Right? What was that about? The mean of the mode. So 1, 2, 2, 3. The mode is 2, the mean is 2. Yay. Right? So when I say explain, sometimes give me an example is plenty. So let me go ahead and give you the answer key.
How do you explain standard deviation?
Oh, how do you get to it? Through the formulas. How do you get to it? You add up a bunch of things that have been squared, and then you take a square root. So squaring things makes them positive, and the result of a square root can never be. So it's like doubly gotta be positive. Does that make sense?
Right.
Yeah.
Okay.
So you can just reference either one of those or both.
And that would work.
And that's exactly the point, yeah. And negative standard deviation would just be really weird. It's like a negative probability. It's probably going to pass.
Negative 15%.
I don't care how bad you feel. That's not going to happen. It's so bad that whoever's sitting near you is also going to get it.
So for the z-score, if I say it's not negative, that's false because
Z-score can be negative. What would negative Z-score mean? It's just below the mean. No, it's not actually that.
No, it's not like
Just have these formulas down.
Because, you know,
Just
the
this.
formula,
That's it.
if our data point is below the mean,
Bring it like that and you can use it as a
Z-score
test.
has to be negative. And that's what, yeah, so that's all you'd say. Negative Z-score just means below the mean. Yeah.
I mean, I did most of it. Like standard, I did this one.
So then our quiz is gonna be next week, so we're gonna apply the Monday, how are we gonna get our
Corrections? Still give it back to us on Monday.
So just remind you guys again, 1G. 1G is on the answer key, of course, but it's not going to be on the test. That's from section 3.4, the box plot and the percentile stuff. Your frequency histogram could definitely look different if you picked a different number of classes or a different starting point, right? So don't freak out if yours doesn't look exactly like that. And I don't think I said this yet. Whenever I give out a practice test, I want you to realize don't do these problems like more than twice, right? Because then you get into the unlucky situation of understanding that problem but not understanding that idea. So the first time I ever did this, I gave out the practice test, didn't even know to say that. Somebody got really upset they got a D. They're like, I did your practice test over and over and over, and I just knew it. And then I'm like, because I gave you a different test. You didn't, you know, you got to know the ideas that are on this, not that specific thing. You with me? And please don't turn this to me. I don't need to see your answers. I just gave you the answer, so I don't need more paper. So you guys look very anxious. If you're ready for the test, you can head out. All right, I'll just keep track. You're my A's.
I know I got that. So, the number is
Oh.
you could say,
Oh. Hey, all right. So you can make corrections on that just like the other one.
on Monday, 7 but the previous.